This is what we're making. A bangle with 4mm round cabochons. And this one has 5, but you can do however many you want. I'm going to make what I call an inside-out bangle. I'm using half-round wire with the half-round on the inside and the flat on the outside. I've got 4mm cabochons, and I've got 4mm thin wall cheniere or tubing. It's seamless, so we don't have to worry about splitting the seam. You can make your own cheniere, but it's just so easy to buy it. Now, normally, and I'll be using this as a bezel, normally your bezel height is 1/3 the height of the stone, but if we do that, we end up with a bezel that's less than 1mm high. That's okay, except you'd have to glue it in, and I want to push the edge of the bezel over. So what we have to do is ensure that our bangle is wide enough to solder our bezel on. Now this, you can see, is just, yeah? And I started with 4mm round wire and I rolled it through my half-round rollers. So it is, I'll just measure it quickly. So it's actually 5.1 wide, and the cheniere is 5, so that's almost perfect. Now you can buy these little 4mm cabochons really cheaply, and what I'm going to do is I'm going to put 5 of these on, and you don't want to solder right next to your solder joint or it'll open up. So the solder joint is here, and I've got my mark here. Now you can either curve the end of the cheniere a little bit, or you can file a little flat on where it goes. It's just that it needs to touch 100%, and if you look, you can see there's a little edge that doesn't touch. So that's why we have to either file a flat or curve the bottom of the cheniere. For this bangle I used 4mm round wire that I rolled through my half-round rollers. So it ended up 5mm wide with a flat outside with the half-round on the inside. Now you can use sheet or strip. I would make it 1.5 thick, and it needs to be 5mm wide because the cheniere or the tubing that we're using for this is 4mm inside diameter, but it's 5mm outside diameter. So this tubing needs to go to the edge of the metal. Yeah. Now I use a cheniere cutter. Basically it's a cheniere holder that gives me the exact length each time I cut a piece. And for these bezels, thin wall cheniere is fantastic because there's no solder joint that you have to deal with. I use Tim McCrate's pattern in the back of his book for getting an equal number of stones on things. I'm using 5 on this one, and we just want to avoid placing one where the solder joint is on our bangle. So it would be standard, get this out, you get your bangle size, measure the inside diameter, add the thickness of your wire, multiply by pi, and it'll give you the length. So make your bangle first. So I'm just going to run my file across, and you can see it doesn't take much for a flat. And when that's on there and soldered, there's only the slightest bit that's going to be visible past the edge of it where it's been filed, so it'll be easy to polish it up. So now we're going to put this in a third hand, flex the inside of this, and place our solder on the inside of this. Hard solder. Now I'm just going to put the smallest amount of flux on the metal on the bottom of the cheniere, and I'm going to drop 3 bits of hard solder down inside. The reason I'm putting the smallest amount on is we don't want it to bubble vigorously and bounce either the cheniere or the solder off. Yeah? So place the cheniere in with our flux brush, and then we want to warm up the flux, push the solder so it's touching the side of the cheniere and the base. Now we're just going to do these one at a time. Your same old neutral flame. About 100 ml long with gas, and then oxy just until the orange goes out. Now gently heat this from the bottom until the flux dries out. And then we want to push our solder around with our solder pick to get it where we want. If it's all touching the bottom of this setting, and it's all in one lump, as long as it's touching the tubing, it doesn't really matter because it will spread around. Yeah. So now I'm just going to heat this up. I'm about 50 mil away on the bottom. The flux will go clear there, and shortly the solder should run like that, and I never had to come up on the top at all. Just make sure that you have a nice smooth line of solder all the way around, and you can either quench this or not. I would quench it just so that I can handle it to shift it up to the next one. Just work all the way around. I'm going to zoom in on this one so you can see. So, same neutral flame. Now this is a number 7 tip on my Smith's mini torch, so it's a fairly decent amount of flame. So I'm just drying the flux, pushing the solder where I want it, preferably on the inside. And then 50 mil away, just heating directly underneath. And you'll notice that the flame starts to go yellow, and that's because the molecules are starting to jump off the surface, and we know that it's close to the right temperature when it does that. So our flux is nice and clear, and then shortly our solder should flow. Ta-da! So just keep quenching, placing, and soldering. Now the reason I'm doing all of my heating from underneath is, one of the reasons is, it's easier to see what's going on because your flame isn't in the way. And with the thin bezel, if you're heating it from the top, more often than not the solder jumps up on the bezel rather than flowing around the base. So this way we're using the base metal to heat the bezel, and we know that solder always goes towards the hottest bit of metal, so by heating it this way, it will stay on the bottom where we want it. Okay, that's our last one. I put 5 on this one. And at this point, have a really good look. Make sure that you can see the meniscus, the curve between the two bits that you've soldered together, all the way around. Pickle it, and then we'll be ready to set the stones. Now, I cut these bezels 1.7 high. The cabochon is only 2 mil high, which means I'm going to either sand or file these back about 1/2 mil. And then I'm going to slightly thin the top edge with a file. So we'll file it at like a 45-degree angle. And then we'll set the stones. After the stones are set, then I'll polish it. I'm out of the pickle. Now, if you did your soldering correctly, you'll have a perfect solder join with absolutely no cleanup, and that's what we want. That's one of the reasons I put the solder on the inside and I heat from underneath. Originally, I was going to thin these edges of the bezel. I'm not going to. I'm going to use a prong setting tool, which is quite handy. I've got various sizes, and what you want is you want this to just fit over the edge, and you can see it has a taper on the inside, so what this is going to do is going to push the bezel all the way around at the same time. Now I suggest that you put this on a ring mandrel so that you can push against it quite hard and not distort the bracelet itself. So I'm going to take a piece of beeswax that I've warmed up, pick up one of the little cabs and place it, and I'll zoom in. So you can see my little cab on the end of my beeswax. And just going to place it inside. Then I'm going to push straight down and rotate my tool. And what it does is it pushes it down and it pushes it over at the same time. Now once your stone isn't moving, you can actually use a hammer on this to get a little bit better job. You could also just use a bezel rocker or a burnisher for this, but in that case you would have to thin the top edge of the bezel to make sure it goes over. So this is our first stone set, and you can see that the metal goes quite a ways over, but that's actually what I wanted on this one. I just want the little bit of black showing, and this thicker edge of the bezel acts a bit like a picture frame, so I don't want to thin this one. So I'm just going to set the rest of the stones now. So all my bezels are pushed over now. I used sterling tubing. I would suggest that you get fine silver because it works so much easier. So the sterling is a bit of a struggle to push over. The fine silver would be brilliant. So in the future I will get fine silver tubing. So to the Tripoli wheel. So it's polished up and ready to go. My little inside out bracelet.